All right, 10th graders. So I am now just getting around to making a video for you about these aldehyde and ketone practice questions that we will have a test on at some point whenever we return back to school. So I have kind of already done some planning around how I'm going to present this to you, but I am going to start out at least with kind of answering number 1 and number 2 on these practice test questions that I gave to several of you, and it's also on the website. So I'm going to kind of go through number 1 and 2 together. I'm going to be comparing letter A, basically letter A and letter A are going to be similar, B obviously similar, pretty much the same exact questions that you'll see, but I'll be comparing heptane 3-one and I'll be comparing it to heptanal. So the first question is asking, draw a structural formula of the molecule. So I'm going to show you what the structural formula would look like for heptane 3-one and heptanal. So the first one is going to look like this. So we've got, this is heptane 3-one. Please notice that I have put the double bonded oxygen on this side of the molecule, though you could put it over here as well. Just the conventions in usual chemistry, you'll see that the wherever you see some kind of functional group, which remembering a functional group for any kind of ketone is going to be this double bonded oxygen. This also knowing this is called a carbonyl, not a carboxyl, but a carbonyl group. So then we would number it 1, 2, 3. The double bonded oxygen is in the middle, not on the end. So that would be what it would look like for letter A. So we can check off letter A on number 1. And then the other one, so then we have heptanal. Heptanal, letter A. This is not the question for number 2. So number 2, it would look like this. So this again, I put this functional group of an aldehyde. I put it on the end of the molecule, but this would be the end, or this would be the end. Both would be considered to be correct, remembering that hept again is 7. You do not have to put this H on here. Know that it is a convention to put the H, just kind of highlighting that this is an aldehyde. So you could essentially also have it just like that, and I would accept that as well. But know that you'll see me drawing this heptanol throughout the rest of this as that. So now at this point we have answered number 2A, so both of those are answered. So I'm not going to write the full answer, but I am going to kind of describe what's going on for letter B. Letter B is the same for both number 1 and number 2. So true or false, this molecule would dissolve in water. True or false, this molecule would dissolve in water. And then I need to justify the answer to include information about the intermolecular forces. I haven't written it, but I have drawn it so you can have an idea of what your answer could look like if you were to draw it, but then you'd need to describe it with your own words. So that being said, letter B. So if I was to, this is on looking again at heptane 3-one, the answer for letter B, 1B, would be, excuse me as I move this out of the way, you'll see my little, it's a little sneak preview for the heptanal. So the answer for this question would be that it is false. False. Heptane 3-one would not dissolve in water. Please notice I've drawn a picture of heptane 3-one. We had discussed in some classes that heptane 3-one is too long of a molecule in order to dissolve in water, and that would be considered to be probably half credit on an answer, but that's not enough information about what's going on for the intermolecular forces. So I drew the intermolecular forces of what would be happening with water. So water would be slightly positive and on the hydrogen and slightly negative on the oxygen. So remembering that oxygen is considered to be more electronegative than hydrogen. So it would try to actually interact with this molecule, but in this case it can't because it can slightly go on this carbonyl, because remembering that this carbonyl group, this oxygen, is going to be significantly more electronegative than this carbon. So it's going to pull on those electrons more. But the rest of the molecule does not have any kind of it does not have any difference in electronegativity because these are just carbons and hydrogens. So this has a very, very long non-polar end. So the hydrogen and the oxygen of water is not going to be able to interact with this long molecule. So the answer for number 1B would be considered to be false. So here we go. And then going down to 2B, moving this over here for you. So 2B, heptanal, is also false. The same idea, the same concept, that it has this non-polar end. This one has a significantly longer non-polar end. So you would end up seeing a little bit like itsy bitsy tiny, not enough to actually see really anything dissolve. So the water would interact a little bit with the end of this molecule, but then it has this really long non-polar end. So that would be the answer for number 2B, would also be false. So that would be then, oops, excuse me, as I was off the screen a little bit. So I have number 1A and A and B, number 2A and B now complete. So number 1 and 2, C. So the question is true or false. Heptanol would evaporate more slowly than this molecule. Justify your answer. Again, similar to the justification for letter B, and both of these are on there. So on letter C, the answer, so it's asking if the evaporate more slowly. It is true it would evaporate more slowly, remembering that anything that has a hydrogen bond, so I've drawn it again. So please notice you've got this heptane 3-one, I've drawn it again so we have a comparison. And then we have heptanol. We're gonna assume that heptanol is a 1-heptanol because I didn't give any other information from that. And I'm gonna kind of answer both of these at the same time if I was to look at heptanol. Heptanol, right here, same idea. What does it mean to be a stronger molecule? It means it's going to evaporate more slowly at room temperature, and it is not going to be, it's going to be significantly stronger. So the slower it evaporates, the stronger the molecule. So these two are stronger. Why is that? Because there is hydrogen bonding present. Remembering all of the intermolecular forces that, out of all the intermolecular forces that exist within the different forces, especially if it's not ionic. So in the stuff that we've learned about, remembering that there's hydrogen bonding, dipole, and London dispersion. So know that this molecule here has all 3 types of forces. Know that the every molecule does have those London dispersion forces, but there is no hydrogen bonding here. There is not a hydrogen bonded to an oxygen, nitrogen, or fluorine. So that is number 1, A, B, and C. Number 2, A, B, and C. So this, in this case, would be true, and this would also be true. So those heptanol would actually evaporate more slowly on this. So please stay tuned on the next video for me to continue on D, E, F, and G on number 1 and 2.